All right, welcome back to 1.6 part 3. Let's finish this off with a super important idea that we're going to use and has application outside of radicals, right? We're going to use this idea of two expressions. We're going to say A plus B and A minus B are related, and with that, one has a plus, one has a minus, but the same numbers. But this relation has a special word. They're called conjugates. They are conjugates. Conjugates. You could say conjugates as well, but normally people say conjugates. So when their expression is multiplied, right, when we multiply these, a minus b, a plus b, we get a squared minus b squared. So that's like our definition of conjugate, is that we get, when we multiply them, we get a difference of squares back, right? That's kind of the idea. So they rationalize the denominator because they create a difference of squares, or they remove radicals that way. It kind of takes out the middle. So let's see what we mean by that. So let's see what is meant. Let's see what is meant for that. Let's take 3 over 2 minus root 5, like that. And I'm going to take a conjugate on the denominator here, right? But I'm going to take the conjugate of 2 minus root 5, and the conjugate of 2 minus root 5 is 2 plus root 5. Because I want to get rid of any radical in the denominator, so I'm going to have to multiply these two across. So on the top, that's fine. That's just going to be 6 plus 3 root 5. That's just it on the top. But on the bottom, it FOILs out difference of squares. I'm going to get 4, and I'm going to get plus 2 root 5 minus 2 root 5. And we can see that the brilliance here is that the middle is going to fall out, and I'm going to get minus 5. And what happens is that this middle piece goes away, right? That's just going to be 0. 2 root 5 minus 2 root 5 is just 0. We learned in the last lesson. So I'm going to get 6 plus 3 root 5. And then 4 minus 5 is negative 1. So I'm just going to get negative 6 plus 3 root 5. And in this case, we actually got rid of the denominator altogether, right? We got rid of the denominator altogether. You could take a GCF out of there if you wanted. You could also say, or there might be cases where you might want to do that, and that could be 2 plus root 5, like that as well too. So there might be cases where you would want to do that. But it makes things a lot simpler to not have to deal with a fraction like that, doesn't it? So let's look at root x minus 2, and we're just going to say x is greater than or equal to 0. And we're going to have root x plus 1. Okay. And that saves us any holes on the denominator because we can't get any negatives from the root anyway, so we're good there. But if we're starting with this, I'm always going to take the conjugate from the bottom here because I'm trying to get rid of the bottom fraction as much as I want. So if I have root x plus 1, my conjugate is going to be root x minus 1. It's always the same thing, different sign, right? It's the same factor, different sign. So on the top, I'm going to get x minus root x minus 2 root x plus 2. So the top might get a little funky, and on the bottom, I'm going to get x minus root x plus root x, and then minus 1. So on the top, am I getting anything to collect? Sure. I'm going to get x minus 3 root x altogether plus 2. And then on the bottom, I'm going to get x minus 1 altogether, right? So now I know that also x cannot equal 1 because otherwise I'll get a whole, like I'll divide by 0. So also x can't equal 1. We're going to do that a lot more in the next unit. Okay, and 15. 15, our last example. Lots of examples here. So let's see what it looks like in general. So I have root a plus root 2b. 2b or not 2b? Well, that looks like 2b. And that's root a minus 2 root 2b. Well, now the conjugate is the same as the top. So what happens there? What falls out? Like, I know what the conjugate is here. that's just going to be root A plus root 2b. Doesn't matter if the conjugate and the existing denominator are the same, we still go, the existing numerator are the same, we still go through with it, right? The denominator and the conjugate are always going to have opposite signs, equal numbers. I'm just going to talk through the multiplication. So I'm going to get root A times root A is A. I'm going to have a root 2ab, right? That goes in that root there, root 2ab. And then I'll get another root 2ab from my inner. And then my last is going to be plus 2b. And then on the denominator, I'm going to get root a. And then I'm going to get minus root 2ab. Actually, I'm going to get plus first, and then I'll get minus root 2ab after. And then I'll get 2b there. Well, let's see what collects, what doesn't. I know that goes away, and the top will collect. So on the top, I'm going to get a plus 2b plus 2ab. And then on the bottom, I'm going to get, and this should be a negative on the bottom. That should be a minus 2b. And why it's negative is because of the conjugate, right? A difference of squares is a difference of squares. So you're always going to have subtraction as the leftover thing instead of addition, right? So I'm going to get a plus root 2ab, and that's out. That looks right. Let's see. Right, that's fine. And then 2 root b plus 2 root b, I have two of them. So the book has a typo. The book is not including this thing here, but we couldn't simplify it, right? They must have multiplied it out. We can't simplify it. So if you're following along with the book, there's a typo there. That 2 needs to be in there regardless, right? Because you're collecting these terms, right? We're not multiplying it, so that 2 can't come out. We're collecting like terms. There's nothing to factor out with. So we're just adding it. So we have 2 times root 2ab. Okay, that's it for this lesson. Let's take a few minutes. Let's look at one or two example problems for a moment, and let's see. Let's do. Let's see. No, that's fine. We'll talk about these in class, but for now, most of these look fairly straightforward. We'll find which ones you're struggling with, and we'll work it out there. But looks good. Thanks for watching. Hope this helps. Use this to kind of like really help with the fundamentals of this topic, and get the idea straight if you didn't quite catch it when we were learning it on the boards. All right. Thanks, Pre-Calc 11. Have a great day.